Have you ever wondered how sometimes you're on a network and you automatically get an IP address? You haven't done anything, but your computer can access the internet and communicate with other devices on the network, which it definitely needs an IP address to do, right? Well, you're probably using a DHCP server, which allocates an address to your device from a specified pool of IP addresses. DHCP stands for Dynamic Host Configuration Protocol, but even this is open to attacks, which is why we need DHCP snooping. In our lab diagram, we have our QFX1 switch, and connected to this are user A and user B. We also have a trusted DHCP server connected that will assign these users their IP addresses. Unfortunately for us, that same dodgy dude or dudette is back, and they've attached a device that can also hand out IP addresses via DHCP. This opens up our network to several kinds of attacks. There are man-in-the-middle attacks where if the spoofed DHCP server manages to allocate an IP address to a host and advertise itself as the gateway, it can intercept traffic before forwarding it on.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
Or it might try a denial of service attack where it just floods the real DHCP server with requests and no other host can get a look in. This is why we need to configure DHCP snooping. We configure interfaces on the switch to be either trusted or non-trusted ports. A trusted port will be where real DHCP communications such as DHCP discover, requests and offers can take place, and these messages will be dropped on a non-trusted port. So DHCP snooping. This is going to be our lab diagram. User A, user B, DHCP server and the spoofed DHCP server. Now for this to work, or for us to see what's happening here, they all need to be on the same VLAN. I'll probably choose either the default VLAN or make one up, VLAN 10. So let's get into it. The first thing I'm going to do is, and what I've done, I've just put the configuration of the DHCP server and the rogue server into a notepad. And the DHCP servers are going to be Cisco routers. And you could use a Cisco router as a DHCP server. Now in a enterprise, it would probably be a Linux server or a Windows server for DHCP. But for our lab purposes, we're going to use two Cisco routers. This one is the dodgy DHCP server. So let me copy and paste this in. And let me save that configuration. Excellent. And then we're going to look at the trusted DHCP server. And this range should give us, what is that, 32 addresses. But because we've got an excluded range, the first IP address that it should give us is .10. Enable this and then paste this in. Okay, that should be good. Okay, so the DHCP server configuration is done. Now we're going to jump on the command line of the Juniper switch. And this I will do from scratch because it's a Juniper course, not a Cisco course, right? I'm sure that I've already deleted the address families on this. Yes. So the first thing I will do, I will create the VLAN. Actually, there's no need to create a VLAN. Let's just go straight into it. I'll put them into the default VLAN. Edit interfaces, XE001 1.0, and the family is Ethernet switching family. I'm going to set the interface mode as access and make it a VLAN member. It's going to be member of the default VLAN. And we're going to do that for all of the interfaces. Let's just do it manually for now. top edit interfaces xe002.0 family Ethernet switching. Now we could up arrow and change to 3. Up arrow, and last one, up arrow twice, and change this one to 4. Up arrow. Let's do a show compare on that. From the top of the configuration, and we can see we've added family Ethernet switching, we've made the interface mode access, and they've all been members of the default VLAN. Let's check the last one, and let's do a commit check to see if that configuration will work for us. Yes, it will, and we've seen from our diagram that user A, user B, the DHCP server, and the dodgy DHCP server, which it could have just been like user C, and then someone's removed user C and put a device on the network that can create or act as a DHCP server. Before I commit it, let's see if we're learning any MAC addresses. Go to the top, run show Ethernet switching table. We're not learning any MAC addresses at the moment. We've committed the command. I could close this down as well. Actually, see something. Alright, so I see 2 IP addresses. So I see the hosts, but I don't see the DHCP servers. So far I can see user A and user B, but I don't see the DHCP server and the spoof DHCP server. I might have to reboot those. Alright, let me reboot those and I'll come back when they're rebooted. So I've restarted the DHCP servers. I've only just restarted them. So let's have a look in the switch table. That's all it was. So we just needed to restart those DHCP servers for some reason. We see all of their MAC addresses. Now let's jump back onto router A and see if I get an IP address. Not router A, user A, sorry. Okay, it hasn't actually been assigned an IP address yet. Maybe the servers haven't come up yet. So let's have a look. All right, the first DHCP server is up, and let's look at the spoofed one. And the spoofed one is also up. Back to host A. No IP addresses yet. If this doesn't work, then I will recheck my DHCP configuration, but I have a feeling it's okay. User B has no connectivity, so that hasn't got an IP address at all. Oh. Well, I released it if it was going to give me one. And now we wait for a little bit and see if these get an IP address. User A and user B. All right, let's try and release, even though there's nothing to release. Release. Okay, that's already been released. There's nothing there. Let's renew it. Jump back onto the DHCP server. And all right, so the only issue I've had is that I didn't enable the interfaces. So let me go into that. Interface G00. There's no shut on the DHCP server 1 and also on the spoofed DHCP server. Yeah. Rookie mistake there. I've enabled them. Right. All live troubleshooting. Let's see if we get an IP address now. Let's see if this one's been given an IP address. So that one has got its IP address. And you see here, they've both received IP addresses, but user A has received its IP address from the spoofed DHCP server, whereas user B has received it from the trusted DHCP server. And this obviously is an issue because user B will be able to use the network resources, get out to the internet, but user B will think that it's authorized to do so, but it won't be. And if it ever wanted to go to its default gateway is the IP address on the spoofed DHCP server. Now, as we saw in the video, we would be able to mitigate that or resolve that with DHCP snooping. But unfortunately, on the VQFX platform, we don't have, or the commands don't work. But there is another way that we can actually try to resolve this, and that's with using a firewall filter. Now, if I done a firewall filter where I stopped DHCP packets coming in of the spoofed DHCP server, then the only option that the users will have for DHCP would be from the trusted server. So what I'm going to do, I'm going to set up that now. And obviously, guys, I understand that this is not how DHCP snooping works. And there's some other features that we're going to look at, like dynamic ARP inspection and IP source guard, that look at the DHCP snooping table, which obviously we can't do either. So we will cover the theory. Let's set that up now. Set firewall. Now let me just check the interface. So it's for XE004, and DHCP always uses port 67 coming in from the server and always towards port 68 for the client. So these are the ones that I'm going to block. Set firewall family. This is for a layer 2 firewall. Ethernet switching. We're going to use a filter, and I'm going to call it block the rogue. Oops, spelling that right. Block the rogue DHCP server. Now we need a term, and the term is just going to be, we're going to block the bad servers. And we're going to use the DHCP port, which is protocol, which is, I think it uses UDP. From. All right. Block. Okay. Let me say block bad servers. I'm gonna make it an edit and see if that will work. So let's go to the front. Edit. Yeah. And set from. And see if protocol is here now for me. All right, maybe another way I can do this. IP protocol. IP protocol. UDP, okay. All right, that one worked for me. And then the next one will be, so we set it from, just fat fingering everything, set it from the source port 67, and the destination port will be 68. And then if this is matched, we're going to drop it like a ninja silently. And then we need something to accept everything out. So I will probably add another term here. If I say up, set term from everything else. then accept. I think that's it. Let me commit check that and see if that went all right. Looks good. Let me just do a top show compare and see, just double check everything. So we've got a firewall family filter for the layer 2. The filter is called block rogue DHCP servers. The term, and this doesn't have to be, the term doesn't have to be a word. It could be a number. It could be like term 1, term 2. But I said term is going to block bad servers from this source port going to this destination port using the protocol UDP. We're going to drop it. And for everything else, we're going to accept. And the last part of the firewall filter, we have to apply that to an interface. Now we saw that this interface is XE004. And we know that this is working because user A got a rogue IP address, yeah? So we set interface XE004.0 for the family Ethernet switching filter for input incoming traffic. It's going to be called, what did I call it? Block rogue DHCP. Block and tab rogue DHCP, and let's commit that. Now let's go back to user A. That was the dodgy one. Yeah. Let's renew that DHCP and see what happens. Maybe I have to release it first. This is going to take a bit of a while, but I'll pause until it comes up. Let's just check it before I renew. So the IP address is still 18.0.0.10. So let me release that IP address first. Yeah, that's been released. And now let's renew it and see what IP address it gives us. Right, and it's giving us one from the trusted range now. From the 192.168.0.10 to .30 network. And this is because the rogue DHCP server has been blocked. Alright, so that's it for this video. I hope you've learned something and we'll move on to the next lab.
It's question time. Question 1. What does DHCP stand for in the context of networking? A. Dynamic Host Configuration Protocol. B. Domain Host Configuration Protocol. C. Distributed Host Connection Protocol. D. Digital Host Communication Protocol. The answer is A. DHCP stands for Dynamic Host Configuration Protocol, which is a network management protocol used to dynamically assign IP addresses and other network configuration parameters to devices on a network, facilitating efficient and automated network setup. Question 2. What does DHCP snooping do in the context of network security? A. Encrypts data transmissions between hosts and servers. B. Prevents unauthorized DHCP servers from assigning IP addresses. C. Facilitates dynamic routing in a network. D. Monitors and controls DNS resolution requests. The answer is B. DHCP snooping, in the context of network security, is a feature that helps safeguard against malicious or unauthorized DHCP servers by actively monitoring and filtering DHCP messages, allowing only authorized servers to assign IP addresses to devices on the network. Question 3. What does DHCP, Dynamic Host Configuration Protocol, do in a network? A. Assigns IP addresses and network configuration to devices dynamically. B. Transmits data between domain servers. C. Secures network connections with encryption. D. Allocates bandwidth for data transmission. The answer is A. DHCP, Dynamic Host Configuration Protocol, is a network protocol that dynamically provides IP addresses and other network configuration information, such as subnet mask, default gateway, and DNS server addresses to devices on a network, facilitating automatic and efficient network setup. To get the complete question banks for all the JNCISENT videos, drop us an email at info@rittercoach.com.